Hello, and this is our first presentation for ENGI 460 Digital Simulation. We are Alana, Shin, and Abigail. In this presentation, we will go over the three types of simulations, an example of each type, the history of Monte Carlo, and the differences between all three simulation types.
Discrete event simulation simulates the operations of a system where the event's change of state in the system has occurred at a particular instant in time. Basically, events that are countable. There are no changes in the system between each event. It is an activity-based simulation because the system only updates when an activity occurs at a specific recorded time. So it tracks the event and when the event occurs and not the time. The continuous simulation is slightly different. It actually is a simulation that models an event or system that is continuously changing over time, and there's an infinite change of state in the events of the system. The Monte Carlo simulation is a probability simulation for difficult to predict outcomes because of several random variables. It's used to model a system by taking into account the probability of uncertainties and risk using random numbers in forecasting models instead of making certain assumptions. It yields a range of results that will be used to model likelihood of future events. It also uses different types of probability distributions such as normal, log normal, uniform, and several others depending on the event or system that is being modeled.
A common example of a discrete event is modeling after a queue. Our example that we will discuss is waiting in line at Hay Cow at Liberty University. The system entities are the customers in the queue, the cashiers, and the cooks. The system events are the customer arrival, the customer departure, and when the employee begins service. The system states are the number of customers in the queue, the cashier status if they are idle or not, and the cook status if they are idle or not. The random variables that need to be characterized to model the system stochastically are the customer inter-arrival time, the cashier service time, and the cook service time. Continuous simulation can be seen in most of the technology that we use today because it is used to represent continuously changing systems. An example of where we can use continuous simulation is if we want to simulate the polar ice cap melting. This is a continuous event with no start or ending point, and the polar ice cap will continue to melt and freeze and melt and freeze. Therefore, we can simulate this on the computer using a continuous simulation. Lastly, a prime example that we have seen of Monte Carlo simulation is during class with the skip problem. A company owns a certain amount of skips that can be hired, and on a certain day, a number of people wish to rent a single skip. The amount of people arriving follows a Poisson distribution. Using Monte Carlo simulation, we can find the optimal number of skips that the company should have on hand each day.
Here's some history about Monte Carlo and how it came about. In 1946, it started out with some physicists at the Los Alamos laboratory where they were researching radiation shielding. They collected a lot of data, and most of that data included the average distance that a neutron would have to travel in order for it to collide with the nucleus of an atom. It also had information about the amount of energy that was being released from that collision. Even though they had all of this data, it still didn't help them to predict the next collision that would happen or the amount of energy that would be released from that. So they couldn't use conventional mathematical methods. They had to figure out something else. Stanislaw Ulam, another physicist, was the one to come up with the idea of using random experimenting. And the way he came up with this was that he was ill for a while, a period of time, and he was playing solitaire a lot, and he wanted to come up with some way of predicting a successful play. And he started out using abstract thinking, coming up with some type of algorithm to predict exactly when that play would happen. But he quickly figured out this wasn't the best route to go because there were so many different ways or combinations of the cards to be laid out. So he came up with the idea of just sitting out a couple hands and then counting the number of successful plays through that. And he found out that there was a way to figure out the probability through doing random plays and counting up the successful ones. So later he talked to John von Neumann, another physicist, about this method. And John von Neumann was the one to come up with the actual equations to actually model this randomization. So through them working together, they had to come up with some type of code name for the process. And their colleague, Nicholas Metropolis, was the one to suggest using the name Monte Carlo. And this is from a Monte Carlo casino in Monaco, where Ullum's uncle would gamble all the time with the money that he would borrow from relatives. And that's how the name came about. Here's some differences between Monte Carlo simulation versus the continuous and discrete simulations. Continuous and discrete simulations model events or systems over a period of time, whereas Monte Carlo simulation focuses on the decision making. The continuous and discrete simulations have functions associated with them, wherein they can be modeled through graphing, whereas Monte Carlo simulations work with more difficult problems, which are harder to quantify through mathematical formulations.
Sources cited, yada yada yada. Thank you for watching.